Good morning, children. Today we are going to discuss how we can calculate the potential of a number of discrete point charges are distributed over various places, and what will be the net potential of that discrete point charges together makes. So in previous class we have seen that how to calculate the potential of a point charge placed at a particular point, and it was equal to V is equal to 1 by 4 pi epsilon naught into Q divided by R. So here we are considering a number of charges, discrete point charges Q1, Q2, Q3 etc. to Qn, placed at a distances R1, R2, R3 and Rn. They are all these point charges Q1, Q2, Q3 etc. Qn have a common origin, or that is placed at a common point P. So we need to calculate the electric potential at the point P by all these charges, discrete point charges placed at various distances R1, R2, R3 up to Rn. So we know that in order to find out this potential of each charge at the point P, so first of all what we need to do, we need to calculate the potential of point charge Q1 at the point P, and again Q2 at the point P, Q3 at the point P and Qn at the point P separately. So let us find out the first. Let's find the first potential. The potential of charge Q1 at the point P, okay, can be represented by V1. So as per the equation, we know that it is 1 by 4 pi epsilon 0. Then what is the charge? Charge is Q1 divided by what is the distance? That is R1. Similarly, we need to find out the potential of various other charges at the point P that can be written as by, that is Q2, Q3 etc. up to Qn. So we can find out the potential of point charge by point charge Q2 can be represented as V2, that is 1 by 4 pi epsilon naught into Q2 divided by R2. Again V3 is equal to 1 by 4 pi epsilon naught Q3 divided by R3 etc. And what will be the charge, the potential Vn due to the charge Qn at the point P will be 1 by 4 pi epsilon naught into Qn divided by Rn. By the superposition, principle of superposition, the net potential will be the algebraic sum of the potential of all the individual charges. Okay, that is the algebraic sum of those all the potential by the individual charges. The net charge V is equal to, what will be the net charge V? That will be V1 plus V2 plus V3 plus etc. plus Vn. V is equal to, what is V1? 1 by 4 pi epsilon naught Q1 divided by R1 plus 1 by 4 pi epsilon 0 Q2 divided by R2 plus 1 by 4 pi epsilon naught Q3 divided by R3 plus etc. plus 1 by 4 pi epsilon naught into Qn divided by Rn. Okay, so that is equal to, here there are some constant n. 1 by 4 pi epsilon 0 is a constant n, so that can be taken as a common, and 1 by 4 pi epsilon naught. Then what will remain there? Here Q1 divided by R1 plus Q2 divided by R2 plus Q3 divided by R3 plus etc. plus Qn divided by Rn. So this is the potential, net potential of a number of various charges distributed at different points. So the net charge will be the algebraic sum of the potential of individual charges. Now we are going to discuss the potential due to an electric dipole. So here consider an electric dipole separated by a distance 2a. A dipole AB is separated by a distance 2a, constituting two charges, minus q at point A and plus q at the point B. Consider the midpoint of this AB and consider another point situated at B and a distance r from the midpoint O, and the angle between OP. So POB is theta. Then now, and consider that the distance r is much greater than the distance A. If this is 2a and from A to O will be A. So consider that the distance r is much greater than the distance A. Now the electrostatic potential at point P due to the positive charge Q. What will be the electrostatic potential due to the positive charge at B? That can be written as, so we can write as it is VB, the potential, electrostatic potential at the point B, VB is equal to, what is its value? 1 by 4 pi epsilon 0 into, and what is the charge? The charge is Q, and divide, what is the distance? That is, distance is PB or BP. Now the same way we can find out the electrostatic potential due to the negative charge at the point A at the point B will be VB. So VA is equal to 1 by 4 pi epsilon 0 into, and here the charge is Q and the what is the distance? The distance is AP. And also it has a negative sign because this is negative charge. Now, so we have got the electrostatic potential at the two points of the dipole A and B. Now, as per the principle of superposition, and the net electrostatic potential will be the algebraic sum of the electrostatic potential at the point A and the electrostatic potential at the point B. So therefore the net potential can be written as V is equal to VB plus VA. So that can be written as, what is VB? 1 by 4 pi epsilon naught into Q divided by BP plus minus of 1 by 4 pi epsilon naught into Q divided by AP. Okay, this constant time, that is 1 by 4 pi epsilon naught, can be taken out. Okay, and again Q also common there, so Q also can be taken out. Q divided by 4 pi epsilon 0 into, then what will be remain there? 1 by BP minus 1 by AP. Okay. This can be simplified as Q divided by 4 pi epsilon 0 into. So, to find out the LCM, that is BP into AP again BP minus AP. Okay. From the figure itself we can understand that the distance BP is slightly less than R and the distance AP is slightly greater than R. Also consider that the distance AR is much greater than A. The BP into AP. Okay. So the BP into AP can be written as BP into AP can be write as R square. Okay. And what will be BP minus AP? What is the BP minus AP will be? That will be, okay, AC. This is the point A. That means the difference between these two sides, okay, will be AC. AC will be the difference between this BP and AP. Okay. Also the angle PAB, angle PAB is equal to angle POB. Okay. Also the assumption is PAB is equal to angle POB and that is equal to theta. Okay. PA minus PB is equal to AC, that is equal to 2A cos theta. Okay. Then AC is equal to 2A cos theta. Then now these equations we are going to, these assumptions we are going to substitute in this equation. So what we will get? Therefore V is equal to Q divided by 4 pi epsilon 0 into, then what is BP minus AP? BP minus AP. Okay. BP minus AP can be written as AC, and AC is equal to 2A cos theta divided by, then here BP into AP can be written as R square. So from this equation we know that Q into 2 into A, okay, or 2AQ. 2AQ we have been already learned in the previous chapter, that is the dipole moment of a dipole. So therefore we can write 1 by 4 pi epsilon 0 into 2AQ can be written as P into cos theta divided by R square. Since P is equal to 2AQ, the term P cos theta, if P cos theta is expressed in the vector notation, so we can write this 1 by 4 pi epsilon 0 into P R divided by R square. R is equal. We assume that the distance R is much greater than A, and this is the value of magnitude of the potential due to an electric dipole.